start the last topic of module 3, which is nothing but Cholesky decomposition and how it works. Already I have explained about the Lou decomposition, and already I have explained the significance of decomposition. Decomposition purpose is to reduce the complexity to solve when the number of simultaneous equations are more than 5. Okay, now Lou decomposition also we completed. Then the question is, what is Cholesky decomposition and how does it work and what is the significance of it? So Cholesky decomposition is also a decomposition methodology in which we can decompose the matrix in terms of lower and upper triangular matrix. Why we want to express in lower and upper triangular matrix? Because the upper diagonal elements value will be 0 in lower triangular matrix, and upper triangular matrix below the diagonal element use values and coefficients to solve the much faster way. So decomposition says that if any matrix A is Hermitian matrix, it is not general matrix, it is Hermitian matrix. If any matrix A is Hermitian matrix, then it can be presented directly in the form of product of or lower triangular matrix. So which will be very easy because upper triangular matrix, you know that below that elements it will be 0. So it will be very easy to calculate because now our values of the coefficients will become 50% less and it will be easy for computation. So, but the condition is the matrix should be Hermitian. Any Hermitian matrix. So first I will explain what do you mean by Hermitian. But if let us consider A is the Hermitian matrix, then with the help of Cholesky decomposition, I can write A equals to UH, U to the power H into U. That means Hermitian into U, or A equals to L into L to the power H. That is Hermitian matrix. So see here, you can directly represent any matrix in the form of product of U, UH into or L into LH. So it will be very easy to solve the two upper triangular matrix or lower triangular matrix rather than solving a complete A matrix, because upper triangular or lower triangular matrix will reduce the 50% of the coefficient and it will become 0. So it will be very easy to solve it. Now, what is Hermitian matrix? Hermitian matrix says that any matrix whose complex conjugate will be conjugate and transpose will be the same matrix. That means any matrix whose conjugate, okay, Hermitian matrix means what? First take the conjugate of all the elements and transpose it, and it will result the same matrix. Then such type of matrix is known as Hermitian matrix. Now let us consider, still I did not understand what do you mean by Hermitian matrix. Then in that case I will explain you with one simple example. I have taken any matrix. Let us consider the first row is 1, 4 plus 3i, okay, or 4 plus 3j. Now 1 is real number, 4 plus 3j is complex number. Second row I am writing 4 minus 3j and 5. So now see here, if I take the conjugate, then 4 plus 3 will become 4 minus 3j, and again 4 minus 3j will become 4 plus 3j, and take that conjugate and transpose, you will find the matrix remains same as it is. So such type of matrix is known as Hermitian matrix. And the Cholesky says if any matrix which is Hermitian matrix can be represented in the form of lower or upper triangular matrix, that means it will help you to reduce the complexity of the matrix simplification, because in lower or upper triangular matrix the coefficient of 50%. So again, simple command which we can use it with the help of SciPy library function. So from SciPy we will import lineals and we will say that let us consider my matrix A is nothing but the entry I have given you, and that matrix I'm going to decompose it with lineals.Cholesky. In the LU, it was LU. Cholesky means CHOLESKY-A. It will give you the matrix in the proper format. So my dear friend, one concept is very simple. Why we want this decomposition and what is the significance of this decomposition which I have explained. So Cholesky will make the matrix, Hermitian matrix, into the product of UH into U. That means again UH represents Hermitian of U and LH represents Hermitian of L. So in that case, we can say our matrix will be represented in the form of lower and upper triangular matrix, and which will make the computation very much simpler way, because 50% of the matrix elements will become 0 and it is easy to solve the equation. So again, when we are having, let us consider number of equations, simultaneously equations, number is more than 4 or more than 5, then I have to write one matrix, that matrix with the coefficient and find this matrix is Hermitian matrix or not. That means, is it this matrix? Once we take the conjugate of each element and transpose, the matrix remains same. If it follows these properties, then we will go with the breaking Cholesky decomposition, where we can represent this matrix in the form of upper triangular matrix, product of upper triangular matrix, or the product of lower triangular matrix, and then it will be easy for us to solve that matrix. That means it will be easy for us to solve that set of given linear equations to find the variables values. So my dear friend, I have explained the Cholesky decomposition. In order to apply the Cholesky decomposition, the condition, the prime condition is what? The matrix of the coefficient should be in the form of Hermitian matrix. That means take the conjugate and take the transpose, and if it remains the matrix same, then we will say it is a Cholesky decomposition. And similar, the small topics of the last of this is eigenvalues and eigenvectors of the module 3, which I have already explained in module 2. In order to find, suppose you have any matrix, you know that we need to find the eigenvalues or eigenvectors, and initially mathematics we will do lot of calculation, A minus lambda into y equals to 0, where we need to find the values of lambda. If you do remember this mathematics concept which you have studied in third semester. But here the Python code will work very simple way. It will take the command of lineals.eig to find the eigenvalues, EIG, VL's values, and EIG means vectors. So if you have any matrix A, just write it on that lineals.eig A. It will give you eigenvectors. Or if you want to find eigenvalues, it will give you EIG, LING, lineals.eig, VLU, and A. So with the help of these two commands which was there, we have solved in NumPy also. Similarly, we can do it in SciPy also, because lineals will be present in NumPy as well as in SciPy. But some of the optimization scheme which will not be there in the NumPy, we will take the SciPy library function and we will try to solve it. So SciPy is having much commands or sub packages which NumPy is not having. Like we have solved this optimization scheme, then finding, decomposition, all these things, etc. So SciPy is having more sub packages than NumPy, but lineals command is there in the NumPy also and in SciPy also. And already in module 2, I have solved it with the NumPy, the lineals command, and there also we have found the determinant, matrix, eigenvalues, and eigenvectors. So this one was the last topic of module 3, which I have explained you. Thank you.